This is the first video lecture for the week 1. In this video lecture, we discuss the course plan and we start the topic number 1 with functions and the type of functions. Let's begin with course plan. This is the fall semester 20FL, academic year 2020-2021, course name Calculus 1, course code MTDR 1106, credit hours 4. This is my email which I already shared in the Blackboard. Let me give you the brief introduction about the course Calculus 1. There are two Calculus 1 in the engineering program, Calculus 1 and Calculus 2. This is the first in the sequence. In this course Calculus 1, we study limits, continuity, differentiation, and integration, and their applications. Then, this is the teaching schedule which has been planned for the next 15 weeks, starting from week 1, dated 11 October 2020. There are 4 topics in the course Calculus 1. 1. Limits and continuity. It will be covered in 2 weeks. Second, differentiation, which will be covered in 4 weeks, that is 3 to 6. And we have third topic, application of differentiation, from week 7 to week 10. And the last topic, integration, from week 11 to week 14. We start the classes this week, that is 11th October, and we are going to end in the classes by 14th January 2021. Then we have a 15th week starting from 17th January, which will be used for revision, retest, re-exam, etc. Then we have 1 week of preparatory holidays from 24th January to 28th January. Then you will be having the semester end examination, that is the final examination, starting from 30th January 2021 and ending by 11th February 2021. I already mentioned this textbook. Please try to get it from the library, and it is very important to have a book with you along with the video lecture what we are uploading. So it's very important to get this book from the library. And then we have a assessment. The course, you will be assessed by 4 components, that is quizzes, midterm exam, homework assignment, and the final examination. There will be 3 quizzes, 15 marks, 1 midterm examination, 25 marks, 2 homework assignment, 20 marks. So total continuous marks will be 60, and the final examination will be 40 marks. So the 100 marks is distributed like this. It's very important to note that there will be only 1 live class every week. Means we have 15 weeks. That means we will be having 15 live class in this semester. And your absence should not exceed 30%. That means minimum you can maximum you can remain absent for 4 live classes. If you remain 5 live classes, you will not be able to write or appear for final examination. So please remember that the maximum you can remain absent for the live classes I am talking, up to 4 classes you can miss. If you miss the fifth class, it will exceed 30%. Then you will not be allowed to appear for the final examination. And I don't see any reason for remaining absent, because you will be attending only one class in a week, and in whole semester, that is of 15 week, you will be attending only 15 classes. That is each class 2 hours, every week one class. So don't remain absent. It's very important, because as I told you, I will be uploading 2 video class every week on Thursday, and you have to watch those video lectures as many times as you want till you understand the concept, and then note down the important points, and list out list the questions. And then when you come for the live class in the following week, you are free to ask any questions regarding those 2 video lecture uploaded. So it's very important. The live class is to clarify your doubts, and then to give you additional information, or additional what you call uh, giving you additional information, as well as understanding of the what we taught in the that particular in the video lecture. So it's very important that you should have a clear cut, that go through the video lecture uploaded, list the questions, and be ready to ask the questions during the live classes, which will be held weekly once, of 2 hours duration. Regarding plagiarism, this is a very important one. So whenever we give you any homework assignment, or whenever you're writing homework questions, and also you should not copy the work of your friends, or you cannot copy directly from any source. So it's very, very important that you must write, or you must do your work on your own without anybody's help. Of course, the video lectures are there to help you out, and any doubts you have before writing, or you can ask, you can clarify the doubts. So this is regarding the course plan, the teaching schedule, textbook, assessment, absent policy, plagiarism policy. So let's begin with the first topic, that is limits and continuity. Before we start the main topic, we have to understand certain fundamentals of calculus. Please remember that the language of calculus is function, because in the calculus we study limit, continuity, derivatives, and integration, and we find the limits, continuity, derivative, and integration of a function. So therefore it's very, very important to understand the meaning of the word function. So let me define first what do you mean by a function, and it's a very, very important. It is a language of calculus. So The definition of a function. If we have two sets A and B, then a function from the set A to B. So here it's very important that the first set is A, the second set is B, then we are having a function from the set A to B. So we have AB are two sets and we are establishing a function from the set A to set B. So function from the set A to B is a rule, or it is a law, or it is a property, or it is a relation that assigns to each element of A. That means each means all the element of the set A. How many? Exactly one element of B. That means for all the elements of A, we should have only one element of B related. So in the definition of the function, there are two important points. One is all the elements of A are to be related, and they are to be related to exactly one element of B. So let me put this definition in the form of set. A and B are the two sets, and the function from A to B is a set F. So this F is the notation for the function. So this F is a function which is consist of ordered pair. Ordered pair means A comma B is a pair. Ordered means A from this capital A, B from capital B. So this is ordered pair. Pair means two, order means the position is fixed. A comma B is not equal to B comma A. So ordered means you cannot change the places of AB. So AB are the two sets. A function from the set A to B is a set F, is a ordered pair in A cross B, that is the Cartesian product of two sets, such that for each A belongs to A, there exists a unique. Unique means only one. B belongs to B. Means A comma B must be in F. So let me just give you the definition of the function in the form of Venn diagram. We have a set A with three elements 1, 2, 3. We have a set B with four elements M, N, P, Q. 1 is related to M, 2 is related to N, 3 is related to Q. Note that there are three elements and all the three elements are related. That is, the first condition is satisfied. The second condition, all the element of A must be related to only one element of B. See that 1 is related to only one element M, 2 is related to only one element N, 3 is related to only one element Q. To get it, P is not related, but means there can be an element or in B which may not be related to any element here, but in the function all the elements of these are related and they are related to only one. If the same thing, if I want to put in this definition form, then F is equal to, see that I must write A cross B, that is the Cartesian product, the A from A, B from B, that means 1 comma M, the first element, 2 comma N, second element, 3 comma Q, third element. So this is a function in the A cross B format. This is Venn diagram, and in a very simple way, in a very short way, we can write the function in this format: F colon A arrow B. That is, F is a function from the set A to the set B. The same thing can write in a very very simple way y is equal to fx. Please note that this x is from the set A, this y is from the set B. That is, for all x there is only one y. So this is what the general form, or you can general form of a function. And we will be using in our course this form of a function. But please remember here, this is nothing but this, the meaning of the function is this. So we will be using this general form in the calculus 1. Let us understand the domain, codomain, and range of a function. We have a set A with 4 elements A, B, C, D, set B with 3 elements X, Y, Z. Then what is the domain? The domain of F is the first set, that is, the whole first set is the domain. The codomain of F is B, that is, the entire set B is the codomain. The first set is domain, the second set is codomain. Then the image of B is Y. The image of B is Y. That means these are all what you call uh, these are these are all called X, Y, Z are called images, and these A, B, C, D are called pre-images. So in other words, Y is the image of Y. The image of B is Y. The pre-image of Y is B. So look at it. So all the elements of B are images. All the elements of A are pre-images. Therefore, the image of B is Y. So we write here B is equal to Y. The pre-image of Y is B. So the same in the reverse order. Therefore, the pre-image of Z, because Z is related to A, C, D. Therefore, the pre-image of Z is A, C, and D. And what is the range? The range is those elements which are related from the codomain. So here we have X, Y, Z is the codomain. X is not related to any element. There, the only two elements are related are Y and Z. Therefore, the range of A is Y comma Z. That is, F of A is Y comma Z. So because of this, so what we understood here is, what do you mean by domain? Codomain, range, image, and pre-image. Now let's see the different types of functions. First, let's discuss the algebraic function. There are basically what you call three important functions. One should what you call understand, and the same the functions we will be using, and in finding the limit, continuity, derivative, and integration. The first one is constant function. Y is equal to C. As I told you here in the earlier case, here, this is the general form of the function, right? So in that way, we have here, look at it. So y is equal to C. That means fx is equal to C. That means either we write y, so there is no x. So when there is no x, it is known as constant function, where this C is any real number. Then we have identity function, where x and y are same. That means all the element in A and all the element in y in second set B are same. So that is known as identity function. And the third one is the power function, where x is in the base and the number is in the real number is in the power. So constant functions, no x on the right, Identity function, left and right are same. Power function, base x, and the power is any real number. In particular, let me give an idea about linear function, quadratic function, and cubic function. Linear, the highest power, so this is the linear function, y equal to mx plus c, where m and c are number, x is the variable, and the power of x is 1, therefore it is linear. So quadratic function, ax square plus bx plus c, a, b, c are number, x power 1, here x power is 2, the highest power is 2, therefore it is quadratic function. Cubic, we have power of x is 3, which is the highest, therefore it is called cubic. And this linear quadratic cubic function can be, are in fact the particular form of polynomial function. The polynomial is in general a function of degree n. So that means highest power of x is n here. So this is called the polynomial of degree n, polynomial of degree 3, polynomial of degree 2, polynomial of degree 1, polynomial of degree n, polynomial of degree 1, polynomial of degree 0. Because there is no x, I can write x to the power 0. So the highest power of x is 0. Therefore, constant function is also polynomial function with the degree 0. So this 1, 2, 3, 4, 5, 6 are all polynomial functions. Then we have rational functions. Rational function means we divide two polynomials, that is numerator, and we have a denominator. When we divide two polynomial, we get rational functions. Radical function. The only difference between the radical function and the polynomial function is that this n here, the power n, or the n minus 1, this is all, they are not fractions, they are positives, right? So therefore, here you have to be very careful that radical function means here qx is any polynomial this, and the power is a fraction here. So when we have a power of a what we call a radical, or power of a polynomial is fraction, then we have a radical function. So an example here is y is equal to root x is a radical function. Y is equal to 3 cube root of x is a polynomial, radical function. So radical function has always the power fraction. Polynomial is never a fraction. So it is a whole number. Then we have transcendental function. The next big category of function is a transcendental function. In the transcendental function, we have five different types of function: exponential function, logarithmic function, trigonometric function, inverse trigonometric function, hyperbolic trigonometric function. So let us study all these one by one. First, exponential and logarithm together we study. What do you mean by exponential function? Exponential functions have this form: y is equal to a to the power x. So please note that in a function we have two variable x and y. Y is on the left side, x is on the right side. Now x is in the power now. So look at it in the earlier case. In this case, power function, x is in the base, power is a real number. Now x is in the power, the base is a number. So this is not any real number. This a is positive and it should not be equal to 1. So this the a cannot be negative and should not be 1 also. It should be other than 1 and it should be positive. So this a is called the base of the exponential function and x is any real number. The reason for a positive is that if it is negative, then the function is not defined. That means not all the elements of first set are related. That means you will be left out these two. So then it is not a function. So please remember the exponential function is of the form y is equal to a to the power x, and this a is the base which is positive, not equal to 1. Then we have exponential function of second type where the base a is replaced by e, and we know that this e is an irrational number and its decimal value is approximately equal to this. You can check with the calculator. So this e is actually known as natural base. So then we have a natural exponential function. So y is equal to a raised to x is an exponential function, and y is equal to e raised to x is a natural exponential function. So there are two types of exponential function. Y is equal to a raised to x, where a is not e. When a becomes e, then it is a natural exponential function. Then we have logarithmic function. Please remember that logarithm function are the inverses of exponential function. So note that in mathematics there are many inverses, means opposite. For example, plus and minus are opposite. Multiplication and division are opposite. Square roots are opposite. In calculus, later we will study derivative and integration are opposites, I mean inverses. So therefore, here the logarithm is the inverse of exponential. If I can write exponential function, correspondingly I can write the logarithm function. So look at it how I am defining the logarithmic function. Y is equal to log x to the base a. So when this is true, because this is the logarithm, you should have a corresponding exponential function. So here again, this a is positive and this a cannot be equal to 1. So this is called logarithmic function to the base a. So again we have here the base is changed. So here we have a natural logarithmic function. It's a logarithmic function with base e. So this a is replaced by e. Then we get y is equal to log x to the base e. But we don't write like this. So log x to the base e we write as ln x. This is L, not I. And note that x is always positive. So ln negative, not defined, ln 0, not defined, ln greater than 0 is defined. So this ln x is known as the natural logarithmic function where the base is e. So what is this ln x now? It is the notation for logarithm with the base a. And note that most calculator have buttons log and ln. The log button assumes the base is 10 and ln button assumes the base is equal to a. The logarithmic function with the base 10 is known as common logarithmic function because we use our numbering system as base 10. And note that natural logarithm are mostly used in the calculus. That means in the logarithms, we use always, I mean, natural logarithms only where the base is a. So we have two exponential functions and correspondingly we have two logarithmic functions. So 1, this is 2, this is 3, and this one is 4. So we have two exponential and two logarithmic function. This is and what we call an example that how we convert logarithm to exponential or exponential to logarithm. So this is the exponential function y is equal to a to the power x, and if I want to convert into logarithm, it becomes x is equal to log y to the base a. So note that in the exponential form or in the logarithm form, the base is same a and a, and this is the exponential form. Correspondingly, this is the logarithmic form. That means I go from here to here like this, and if I want to come back, I can go from here to here the opposite way. But in these two cases, don't forget the base A is positive, not equal to 1, and this log y, it cannot be 0. That means other than 0. For example, 2 raised to 5 is equal to 32. This is exponential form. If I want to convert into logarithm, it is log 32 to the base 2 is equal to 5. So this and this are same. This is in exponential form. This is in the logarithmic form. So this is the what you call the method how to convert exponential to logarithm or logarithm to exponential. Then we have trigonometric functions. This is so there are six trigonometric functions which is defined for a right angle triangle, and this is called opposite side, this is called hypotenuse side, and this is called adjacent side. So remember, this adjacent side is denoted by small b, opposite side is denoted by a, and hypotenuse side is denoted by c. Then it is a right angle triangle here, and we are finding the sine of a. So that is this angle we find. So because this a is an angle here, so sine a. So name of the function. There are six trigonometric functions. So these are the sine, cosine, tangent, cosecant, secant, cotangent. These functions can be written in a short form like this. Note that cosecant I write CSC, and the definition sine A is opposite divided by hypotenuse. Hypotenuse opposite by hypotenuse, that is A divided by C. So cos adjacent by hypotenuse, tan opposite by adjacent, cosecant hypotenuse by opposite, secant hypotenuse by adjacent, cotangent adjacent by opposite. So these are the what you call six trigonometric function. The name, the short forms, the definition. This is a very important table. Here I'm writing the six trigonometric function. The only difference between here is that here I have used a here. So here actually we write x because I'm talking about the trigonometric function and we are using the two letters y and x. So y is always on the left, x is on the right. So these are the six trigonometric function. So this can also be written as y is equal to sine x, y is equal to cosine x, like that. So I can convert, I can write sine in terms of tan and secant like this. So please remember here, tan is sine by cosine, or cotangent is cosine by sine, Sec is 1 by cosine. Cosecant is 1 by sine. So 1 by sec is cosine. 1 by tan is cotangent. Sec x by tan x is cosecant. 1 by cosecant is sine. So this is how we convert or we convert from, we can write sine x using tan x secant, sine x using cosecant x. This is a very important table and which will be very helpful when we are finding the limits, derivative and integration of trigonometric function at the later stage. Then we have some trigonometric identities, that is how the cosecant and 1 by sine are related. These are the Pythagoras identities, that is sine square cos square is 1, sec square is equal to 1 plus tan square, cosecant square is 1 plus cotangent square theta. So here theta is nothing but, here we have used, but this theta is x here, that is y is equal to like. Then we have the formula sine half, that is a half angle formula. This is product to sum formula, that is product of two functions, how we convert it into sum or difference. Sum to product, that is sin x plus sin y, how you convert into product formula. So these are reciprocal, Pythagorean, half angle, product to sum, and sum to product. So these are also very helpful in finding the derivative and integration at the later stage. Then we have inverse trigonometric functions. So as we have seen, let me first define one simple inverse function. The inverse sine function is the function which is denoted like this. So note that it is not uh, like what we call exponent x to the power minus 1. How you write x to the power minus 1? You can write x to the power of minus 1 as 1 upon x, but we don't write this. This is just a symbol to denote it is inverse sine function. So we write, look at it, y is equal to sine inverse x. If I want to remove this, if I want to remove this sine inverse symbol, then x is equal to sine y. So y is equal to sine inverse x and x is equal to sine y are the same. So this is in the inverse form, this is without the inverse form. So like that, we have 6 trigonometric function. Correspondingly, we will be having 6 inverse trigonometric functions. And this inverse function can also be written using, can also be called arc sine function, that is arc sin. So this is the short form for that. So either we write y is equal to sine inverse x or y is equal to arc sin. So they are the same. Means we have 6 inverse trigonometric function. They are y is equal to sine inverse x or y is equal to arc sine x and cos inverse x, like that. We have 6. This is the domain and this is the range, and we have already studied what do you mean by domain and the range in the definition of the function. So we have 6 trigonometric function. Correspondingly, we have 6 inverse trigonometric functions. Then we have hyperbolic function, so which is denoted as sine hx. So this is sine hyperbolic x, which is defined in the form in the form of exponential function. That is Sine hyperbolic x is equal to e to the power x minus e to the power minus x divided by 2. And note that cosecant hyperbolic x is 1 upon sine hyperbolic x. So that means it will be inverse 2 divided by this. Cos hyperbolic x, just we change this minus to plus, and then sec is 1 upon cos hyperbolic, therefore we take the inverse of this. Tan hyperbolic is sine hyperbolic divided by cos hyperbolic. So this and this we divide 2 cancels this. And cotangent hyperbolic is 1 upon tan. So we take the alternative of this. So we have 6 hyperbolic functions: sine hyperbolic, cos hyperbolic, tan hyperbolic, cosecant, secant, and cot hyperbolic. That means in the trigonometric function, we have 6 trigonometric functions, 6 inverses, and 6 hyperbolic functions. So in summary, what we have studied in this topic number 1, lecture number 1, we have understood details about the course plan. That means in the course plan, we understood what is the course name, what is the course code, semester, academic year, teaching schedule, how many week, starting week, ending week, when the classes start, when the classes, ends, when are the examination, what is the textbook, what is the assessment, how we are assessing, what is the absence policy, and what is plagiarism. In the second part, we understood what do you mean by functions. Then some terminology we understood: domain, codomain, range, image, pre-image, etc. Then the most important is what are the different types of function: algebraic functions, then transcendental function. In the transcendental function, exponential, logarithms, trigonometric, inverse trigonometric, and hyperbolic trigonometric function. So with this, we end the lecture 1, week 1. Thank you.